Welcome. This is Meenakshi, lecturer, Department of Computer Science, Sita Lakshmi Ramaswamy College, Trichy. Now, we are going to learn the topic 2D transformations in computer graphics. Now, what is transformations? Transformations are the operations applied to an object, 2D object, to change the position of the object or the orientation of the object or the size of the object. That is 2D transformations. There are three types of transformation. The first one is translation. Translation is changing the position of the object in a straight line path from one coordinate location to another. If we want to translate a two-dimensional point x, y to find the new position x dash, y dash by adding tx and ty. That is represented in the equations x dash is equals to x plus tx and y dash is equals to y plus ty. This diagram represents the translation process, that is translating a point P to the new position P dash, that is translation of x, y to x dash, y dash by adding the translation distance tx, ty. Here the translation process is for 2D object. The object is translated from one location to another by adding some values in the x direction and some values in the y direction. So the object is moved from one location to another by adding the translation vectors. This is the matrix form for translation. Matrix form of the equations for x dash and y dash. X dash is equals to x plus ty and y dash is equals to y plus ty. That is represented in the matrix form as the original position P is equals to x and y, and the new position P dash is equals to x dash, y dash, and the translation vector T is equals to tx, ty. So we can write this matrix form as a new equation as P dash is equals to P plus T. P dash represents the new position, P represents the original position, and T is the translation vectors. The second transformation is rotation. That is rotating an object along a circular path in the xy plane. By rotating the object, we can repositioning it. Using the standard trigonometric equations, express the coordinates in the terms of theta and phi. Theta and phi are the angles from original position to the new position. That is, theta is the original angle and phi is the new rotated angle. And the original coordinates are x is equals to r cos phi and y is equals to r sin phi. And the new rotated coordinates are x dash is equals to r cos of phi plus theta is equals to r cos phi cos theta minus r sin phi sin theta. Y dash is equals to r sin of phi plus theta is equals to r cos phi sin theta plus r sin phi cos theta. Now this is the diagrammatic representation of rotation, that is rotating the point P to P dash from the angle phi to the new angle theta. Rotating the points coordinate point x, y to coordinate points x dash, y dash. By applying the equation, we find out x dash is equals to x cos theta minus y sin theta and y dash is equals to x sin theta plus y cos theta. Previous diagram, we have seen the point rotated from one angle to another angle. Now we are going to see a 2D object rotating from one angle to another angle. The left diagram represents the original position of the object and the right diagram represents the rotated object from one angle to another along a circular path in the xy plane. This is the matrix form of rotation. X dash y dash are the new rotated angle. XY are the original position. Cos theta, sin theta, minus sin theta, cos theta matrix is the rotated angle. And we can write the matrix as the equation P dash is equals to P dot R. P dash is the new rotated position. P is the original position and R is the rotated angle, and we can represent the rotation as a matrix. R is equals to cos theta sin theta minus sin theta cos theta. The third transformation is scaling. Scaling is for changing the size of the object. Increase the size of the object or decrease the size of the object. This can be carried out for the polygons by multiplying the scaling factors Sx and Sy to the coordinate values x and y to produce the new coordinates x dash comma y dash, and the equation for x dash and y dash are x dash is equals to x dot sx and y dash is equals to y dot sy, and the matrix form of scaling is x dash y dash is equals to x y, and the diagonal matrix x sx and sy. The common equation for the scaling is P dash is equals to P dot S. P is the original position, S is the scaling factor, and P dash is the new position. This is the diagrammatic representation of scaling. Left one is uniform scaling and right one is ununiform scaling. In the uniform scaling, the scaling factors x and y should be equal. That is, values of x and sx and sy should be equal. And in the case of ununiform scaling, there is no need to be equal scaling factors. Homogeneous coordinates in 2D transformations. Homogeneous coordinates are used in design and construction applications. Now we are doing the transformation, that is translation, rotation and scaling are to fit the picture into the proper position. This homogeneous parameter h to be non-zero value. Then only we can get the proper answer. For our convenience, we can consider the parameter h as the value 1. That is x comma y comma 1 or the coordinate points and the homogeneous coordinate. Homogeneous coordinates for translation. Already we have seen the matrix form of translation with 2 by 2 matrix. Now it is converted to 3 by 3 matrix by adding the homogeneous coordinate and the translation vector tx and ty, and the last row tx, ty and 1 represents the homogeneous coordinate. This is homogeneous coordinates for rotation. Already we have seen the rotation matrix with 2 by 2 matrix, and that matrix is converted as 3 by 3 matrix by adding one more row and column, that is homogeneous coordinates. The theta or angle represents the rotation angle. The last row 1 represents the homogeneous coordinate. This is the matrix representation of homogeneous coordinates for scaling, and this matrix also converted to 3 by 3 matrix by adding one row or column for homogeneous coordinate. The Sx and Sy are the scaling factors. The diagonal last one is represented as the homogeneous coordinate. Composite transformation, that is applying more than one transformation to the same object. First, we need to go through the translation. Two successive translation, that is two continuous translation is applied to the same object. So the translation vectors to be tx1, ty1 and tx2, ty2, because here two translation are going to apply to the object. from the coordinate position P to the final transformed location P dash. Now we are going to see the equation P dash is equals to T of Tx2, Ty2 in dot T of Tx1, Ty1 dot P. Now we have to go through this equation from right to left. Initially we need to take the coordinate position P by applying the translation vector, that is T of Tx1, Ty1. Then we have to apply the another translation T of Tx2, Ty2. So we need to find the new location P dash. This is represented as a matrix form, composite transformation matrix with the homogeneous coordinate. That is why the matrix represented as 3 by 3 matrix. Left side is the two translation, that is second translation and first translation, that is equals to the addition of two translations tx1 plus tx2 ty1 plus ty2, and the following equation represents the same matrix in an equation form. Like two successive transformation, now we are going to see two successive rotation, that is rotating object two times from the point P to produce the new transformed position P dash by applying two angles theta 1, theta 2. Likewise, the same equation is go through from right to left. Right P, that is original point P, is rotated from r of theta 1 and again rotated to r of theta 2 to produce the final transformed position P dash. Here multiplication is applied. The two rotation matrices r of theta 1 dot r of theta 2, that is equals to r of theta 1 plus theta 2. The final result to be additive. P dash is equals to r of theta 1 plus theta 2 dot P. That is the original position P is two times rotated and produce a final position P dash. Like the transformation and rotation, here two successive scaling operation. Scaling operation to be done for the object two times continuously. That is scaling the object from original position P to the new position P dash by applying the scaling factors Sx1 and Sx2 and Sy1 and Sy2. The resulting matrix to be multiplicative. These are the matrix form of two successive scaling Sx1 and Sx2, Sy1 and Sy2. This is 3 by 3 matrix by adding the homogeneous coordinates. The right side matrix is the result matrix, that is multiplicative. The result to be multiplicative in the scaling transformation. General pivot point rotation, that is rotating the object along with the pivot point. Pivot point is any point in the object and the rotation is going to be done about the origin. The three procedures are going to do the process and the diagram represents the procedures. The first point is translate the object so that the pivot point position is moved to the origin. Translate the object means moving the object along a straight line path. The first diagram represents the translation of the object so that the pivot point is moved to the origin. The first diagram, the dot represents the pivot point, the red color dot represents the pivot point, and in the second diagram, that red color point, pivot point is moved to the origin. The second procedure is rotate the object about the origin. The third diagram representing the rotation of the object about the origin. The last point, translate the object so that the pivot point is returned to its original position. The last diagram representing the process. the translation of the object so that the pivot point is returned to its original position but it is rotated. This is called general pivot point rotation. General fixed point scaling. This diagrammatic representation represents the procedure of scaling with respect to the fixed point. In the first diagram, the red color dot represents the fixed point. We need to do the first procedure, translation of the object, so that the fixed point coincides with the origin. Yes, the second diagram representing the procedure. Translation of the object and the fixed point is on the origin. And scaling the object with respect to the origin. The third diagram represents the scaling of the object. The object is now decreased in the size, that is, changing the size of the object is called scaling with respect to the origin. Third procedure is use the inverse translation of step 1 to return the object to the original position. Return the object to its original position using the translation, that is moving the object from one position to another position along a straight line path. This is called general fixed point scaling. Other transformations. There are two more transformations called reflection and shear. Reflection is the transformation produces the mirror image of an object obtained by rotating the object by 180 degree about the x-axis or y-axis or x-y axis. This diagram shows the reflection in x-axis. So, the matrix representation represents only 1 in x-axis and -1 in y-axis, and the last one is homogeneous coordinates. In the diagram, original position is 1, 2, 3 and the reflected position shows 1 dash, 2 dash, 3 dash. This is reflection about x-axis. Here, same reflection is with y-axis and xy axis. The left diagram shows the reflection about the y-axis so that the value of x is equals to 0. That is, the diagram represents the original position 1, 2, 3 in the left side and the reflected position in 1 dash, 2 dash, 3 dash in the right side. That is, this reflection is done only in the y-axis. So the matrix representation is also showing the middle one represents it is a y-axis and the first row represents the x-axis, that is -1, and the last row represents the homogeneous coordinates, and the right side diagram is reflection of object with respect to the straight line y is equals to x. This is done in the same side 1, 2, 3, the same 1 dash, 2 dash, 3 dash. So in the matrix form, the position of 1 is changed. That is, x is changed to y and y is changed to x. The last row is same as for homogeneous coordinates. Shear transformation. Shear is comes under other transformation. Shear is distorts the shape of the object. Here, the shape of the object itself sometimes changed by applying the shear. Two common shearing transformation are shift the coordinate x values and shift the y values. This is the diagrammatic representation of shear. The first diagram represents the original position. The second one represents the shear of x and y coordinates. Thank you.